Okay, good morning. I'm not here today, so I am sending you a lesson as a video. I expect you to take some notes on this because it will make it easier if you follow along and take notes instead of just watching. Or you could just watch and then go back and do it again and take some notes and see if it makes better sense that way, just depending on how you want to do it. You had an assignment yesterday. If you didn't get that finished, you can work on that during class today also. But we're going to talk about some other things today. So let me just go ahead and tell you some of the terminology we're going to use. We're going to talk about something called end behavior, which you already know about, right? So you've already talked about as x approaches negative infinity, what is y doing? Is it going up or down? The other thing we're going to talk about is something that you already know. You already know domain and range. Okay, so this is going to be a little bit challenging because we're going to have two different kinds of notations. And then we're going to have another new kind. We're going to talk about increasing intervals. So yesterday when I was having you talk about and color your intervals where it was increasing or decreasing, as if you were riding a roller coaster. Now we're going to actually put that in interval notation. So it seemed easy yesterday when you were coloring them pretty colors. Now we got to put some numbers with that, which is going to make it a little more challenging. All right, so let's go look at one that's a little simple and we'll figure that one out first, okay? So you've got a cubic function. So this is y equals x cubed. If you want to put that in your calculator, put that in your calculator so you can kind of see it, at least through a graphing calculator, and you can look at your table. All right, but let's just look at the picture of the graph. So either graph it now and hit pause and then come back to it, but I'm not going to pause. Okay, so y approaches what? Okay, this is a little backwards. X is approaching negative infinity. That means on the left. What is y doing? Well, let's go down and look to see what y is doing. It looks like it's going to end up going down. So y approaches negative infinity. So that means it's going down. All right. And then this one's written a little backwards, but it's okay. So we're just going to read y approaches what as x approaches positive infinity. So this is saying on the right, let's say what's happening. Well, on the right, it looks like it's going up. So we're going to say y approaches positive infinity. All right, so I'm going to scroll down a little bit because I got some other stuff to show you. Okay, and the last thing that we're going to talk about right here on this screen is the new thing, the interval in which y is increasing. So when y is increasing, where is y increasing? Well, we're just trying to figure out where is it going up, and we always do it from left to right. So if you were in a roller coaster, okay, you would be sitting, and let's say you go from left to right, you would be going up from the very beginning, right? It'd be going up from the very beginning. It never stops going up. It keeps going up all the way until you get off the graph here, okay? That would not be a very fun roller coaster to ride because when would you come back down? So the interval in which it's increasing, it starts here and it's been increasing. We don't know when it started increasing. We just know it's been increasing ever since we could see the beginning of the graph. So it starts increasing at negative infinity, and then we don't know where it's going to be stopping. So we're just going to say it's going to keep increasing in the entire graph. So we say it like that. So, it kind of looks like the same kind of notation we use with domain and range, which it is, okay? You have your starting point and you have your stopping point. But when we're talking about increasing and decreasing intervals, we only talk about x. We don't talk about y. Okay, so you just got to think roller coaster. Where am I going up on a roller coaster? So let's try looking at this one. This is y equals 1/2 x squared. This is very similar to what you did yesterday when you were taking notes. So go ahead and graph it. And maybe draw a graph if you can, if you want to draw it on graph paper. And then get a colored pencil and maybe color where it's going down and then where it's going up. So I'll give you a couple minutes to do that. Okay, so this is the graph of y equals 1/2 x squared. So it's very important to plot the points because we need to find certain things. Okay, I'm sorry about the dog barking. Anyway, so we're going to determine the end behavior. So we are very familiar with that. So as x approaches, let's do x approaches negative infinity. What is y doing? So we're basically saying, what is y doing on the left side? Well, it's going up. So it is going up on the right, on the left, so it's going up. All right, and then we'll do the next side. If x approaches positive infinity, which means on the right, what is y doing? Well, y is also going to positive infinity. Let me give you a little hint. When this exponent is even, they're both going to be going the same direction. Okay, so that should help you if you're trying to decide what they're doing. All right, so here's the new part. On what interval is the function decreasing? So take a colored pencil at this point and start on the left side. And if your pencil is going down the graph, you are in a decreasing interval. So if I were in a roller coaster, I would be dropping pretty fast until I hit the bottom. Okay? So now we've got to name it in interval notation. This gets a little bit more challenging. So where did it start decreasing? Well, we don't know because it was all the way over to, remember, this is negative infinity. We're only talking about x values. Okay? So where are the y values decreasing? Well, it's going from negative infinity, right, all the way from the left side until it hits 0, okay? And it's kind of questionable. Do we count 0? Do we not count 0? So I guess for this time, let's count 0, okay? But technically, you're not really increasing or decreasing at 0. So I'll get back to you on that one. So I think that we're probably just going to say we're going to count 0 for now. But don't be surprised if we just decide to call it not 0 also. But you got to count 0 as a boundary. So whether we put the equal sign underneath it or not, that's not a big deal right now. All right, so that's your interval where it's decreasing. So if you were in this roller coaster and you could see all these x values, right? It's -1, it's -3, it's -5, -7, la la. All right, it would keep going all the way to negative infinity, but it will definitely start turning at 0. Okay, so now let's go and see where is the interval where the function is increasing. So now we say, well, where are we turning around? So I'm going to color that a different color. I'm going to color that green. And it's going to keep going. And if I could go back up to the top of the graph, it doesn't seem to stop increasing. It keeps just going and going and going. So this is the interval where it is continually increasing. If you need to draw dotted lines to show where it turns, then you can. It turns right there at 0, and it never stops. So we're just going to say it starts increasing at 0, and it keeps going until forever because it just keeps increasing. Okay, and you can maybe count it as 0. All right, so that's it. That's increasing and decreasing interval. It gets kind of challenging because you're using the same notation as domain and range, but we're not talking about domain and range. We're talking, is it going up or is it going down? And we're talking about the x values as if you were on a slide. All right, let's try this one. This is a cubic function. So take a minute and graph that. And then maybe plot some points or at least look at it on your calculator screen. I'll give you a minute to do that. Okay, so I plotted all the points that were on my table that I could fit on my graph. So if you can't remember how to find your table, go to second graph and you'll have a table of numbers. Now mine were all decimals. So I tried to plot them as close as I could to what I thought they should look like. Now, how do you connect the dots? Well, if you're looking at your graph, you know it's going to go like that. So let's connect our dots the way that we see them on our graph. Plus, we know it's a cubic function. So it's going to turn twice, and I'll explain some of that to you later on. when we talk more about polynomials. All right, so I connected my dots. All right, so now let's talk about the domain and the range. Go all the way back to domain and the range. Is there anything that x cannot be? Well, it looks like it's pretty much covered with everything. So it's going to go from negative infinity, and remember we're talking about x when we talk about domain, okay? And then the range, yeah, this is going to keep going, so don't stop at 8. Don't stop when you get there. It's going to keep going and going. So the range will also be negative infinity to positive infinity. Now, if you need to, if you're using graph paper, color where it is increasing. So if I were riding in a roller coaster, I would be going down a hill here, right? So that's not increasing. I would turn when I get to this point. So we're going to go, okay, this is going to go up a hill now. All right, so we're just going to talk about those x values where it is increasing. Let me erase this real quick so these little dots don't get confusing. All right, so what are my x values here? So again, it's really good to label some points. Oh, this one was a crazy one, but it doesn't really matter what the y value is. It matters what the x value is. That's at -2. And remember, that was at like -2 point something, or -3 point. Oh, let me look at that. -3.6. No one cares about the y value. All right, at this point. And then this next one, this point is +2. And what's the y value there? 7.6. I'm looking at my table again on my graphing calculator. All right, so we only care about the x interval, or the x values. So it's increasing from -2 to +2. Let's go ahead and not draw that equal sign, because technically when you're sitting on top of the hill or you're sitting at the bottom of the hill, you're not actually increasing or decreasing. Okay, so that's your interval where you're increasing. Now let's talk about where you're decreasing. Oh, look at that. You got two different intervals where you're going to decrease. You're going to go down here. Oh, I should have left those things on there. Hold on. Put those points back. All right, so now let's talk about where we're decreasing. So starting at the left side, you're sitting in a roller coaster, right? Woo, I'm going down. All right, no, that's not very fun, but you are going down on that interval, right? So this, what are your x values? Well, we don't know where we started decreasing on our x values. So our x value is going to be at -infinity is where we started decreasing. And where did we stop? Where did we hit the bottom? Well, we hit the bottom at -2. Okay, that's it for decreasing. But no, it's not actually, because you went back up the hill, and look at this. Now what are you going to do again? You're going to go down again. Okay, so at the x value of 2, you're going down again. And we're going to keep going until forever, because we don't really know. So we're going to call it infinity. All right, let's do one more. Look at all these little brackets we drew. That's why we learned how to draw brackets. Talk about the end behavior, okay? Go all the way back to end behavior. So as x approaches -infinity, what is y doing? And as x approaches positive infinity, what is y doing? So let's go look. As x approaches -infinity on the left, this is going up. So y is going to infinity. As x approaches positive infinity on the right, y is going down. So y is approaching -infinity. All right, that was a lot of information. I think we need to practice one more. No, I don't want to practice that one. That one's a little too confusing. We'll save that one for later. All right, so you needed to get a piece of paper that looks just like this. It's in the back of the room on the back table by where you normally turn your work in, okay? It says where to begin and end. So go on and get up and go get that paper. And I want you to work on number 1 through 4 today only. But I'm going to do number 1 with you. So pause this and then go get that paper. All right, so you should have gotten the paper. So go ahead and put your